Hi friends, today we are going to learn Strassen'S matrix multiplications by using divide and conquer strategy. So now question is, why Strassen'S matrix multiplications? Regular matrix multiplications used to take more amount of time to perform the multiplications, right? If we are having 2 by 2 matrix, then we required 8 multiplications to perform the task. Yes, of course, we are going to use the additions as well, but number of multiplications is required 8 in 2 by 2 matrix. Now, why we are focused on multiplications? Because multiplication is set of additions, right? So, our focus is to reduce the number of multiplications in order to decrease the time complexity for matrix multiplications. Then, Strassen'S is a mathematician has given the new concept of multiplications. So, as per his algorithm, right, at the place of 8 multiplications, we can use 7 multiplications. That we are going to discuss in details. Under this topic, we are going to learn examples and time complexity analysis. So, let us see that what is Strassen'S matrix multiplications and how it is different from regular matrix multiplications. So, in 2 by 2 matrix, right, when you are going to multiply, Strassen'S algorithm makes 7 multiplications and 18 addition and subtractions. That you are going to learn. And whereas brute force algorithms uses 8 multiplications and 4 additions. So, our focus on these 8 multiplications and 7 multiplication in Strassen'S. So, number of multiplications is decreased by 1, right? But see, at the place of 4 additions, in the Strassen'S multiplications is required 18 addition and or subtractions, right? So, we are ready to give time for addition or subtractions. We are ignoring that time. Our focus is on multiplications. So, let us see that if you are having matrix called 2, 3, 1, 2, right? And you are going to multiply another matrix 1, 2, 1, 3, right? So, how are you going to perform the task? We are going to multiply, and multiplication rule is same in both the functions, right? Number of rows, right, of the first matrix must be equal to the number of column of the second matrix, right? So, we are going to multiply like this: row, column, row, column. So, let us see that we are going to multiply 2 and 1, right, plus 3 into 1, right. Similarly, we have to multiply 2 and 2, 3 and 3. Similarly, this second row, first column, 1 and 1, 2 and 1. Similarly, 1 and 2, 2 and 3. So, you can see that we have performed multiplications like this: first row, first column, first row, second column, second row, first column, second row, second column. And this is the outcomes. How many multiplications you have used? 1, 2, 3, 4, 5, 6, 7, 8. So, if it is 2 by 2 matrix, ordinary multiplications are 8 times, 8 multiplications, right? We have used it. Additions 1, 2, 3, 4, and 4 additions we have performed, right? But in Strassen'S matrix multiplications will have different values. So, what is the outcome of this? Outcome is 2 plus 3, 5, here 4 plus 9, 13, 1 plus 2, 3, 2 plus 6, 8. This is the output of these multiplications. Now, this can be represented as outcomes C. And what is the value of C? These all are the multiplicative factor. And if this is the first matrix, we can write it this place, since 0th row, first column, 0th column, first column, 0th row, first row, 0th column, first column. So this can be represented as A00, A01. This place, row is 1, column is 0, row is 1, column is 1. Like row and column. First values of A, if you are writing A of ij, I is row representations and j is column representations. Similarly, here also we can do it. Since it's a B matrix, we can write it B00, B01, B10, B11, and you are going to perform the task. Alright. So let us see that how you are going to perform the task. Now we are going to apply two matrices. We are having it as I discussed now, A00, A01, A10, A11. We are going to multiply with B00, B01, B10, B11. And we have seen that there are 8 multiplications is required. Now, by taking the same examples, what we are having it here? 2, 3, 1, 2. So here we have 2, 3, 1, 2. And we have 1, 2, 1, 3. Right? Now A00 means 2, A01 is 3. So these all are the values. We are going to note it down. Right? Before you are going to apply Strassen'S matrix multiplications. So let us see that. There are 7 multiplications are well defined. We have to compute that multiplicative factor. M1 is A00, A11. So let us see that what is the value of A00, A11. A00, A11, diagonal element, A00, A11. So it is 2 plus 2, right? 2 plus 2 multiply B00, B11, B00, B11. What is the values? 1, 3. So here we have 1, 3. So if we perform the task, 2 plus 2 is 4, 1 plus 3 is 4, 4 4 is 16. Right? Similarly, we are going to compute M2, A10, A11, A10, A11. So 1 plus 2, 1 plus 2. B00, B00 is 1. Just now we have written it here 1. So 1 plus 2 is 3 into 1 is 3. M3, A00 is 2. We have written A00 as 2 into B01, B11. B01, B11, B01, B11 is nothing but 2, 3. 2 minus 3. B01, B11, 2 minus 3. 2 minus 3. Right? So if we perform the task, what is the values? 2 into minus 1 is minus 2. Similarly, A11 was 2 into B10. B10 is 1. 1 minus B00, we already computed 1. So 1 minus 1, 0. So 0 multiplied by anything is remain 0. No. A00 is 2 plus A01. We have to check what is the value of A01. A01 is 3. Multiplied by B11 was 3. So 2 plus 3 is 5, 5 3 is 15, you got it. Similarly, A10 A10 we have already written in the previous step was 1, 1 minus A00 was 2 into B001 we have already written, and B01 we have written 2. So we are going to multiply. 1 minus 2 is minus 1, 1 plus 2 is 3, 3 into minus 1 is minus 3. Similarly, we are going to compute for these values. A01, what is the value of A01? 3 minus A11 is 2 multiplied by B10 is 1 plus B11 is 3. So if we will compute this, what is the value? 3 minus 2 is 1. 3 plus 1 is 4. 4 minus 4 into 1 is 4. So now we already computed these values M1, M2, M3, M4, M5, M6 and M7. Now there are certain formula of C values, resultant matrix. C is a resultant matrix as you have solved it in previous one. But here you have certain formula. That formula we have to apply based on these multiplications. There are 7 multiplications. One by one you are going to compute these values. How are you going to compute these values? Let us see that. What is required here? M1. What is the value of M1? M1 is 16. So M1 is 16 plus M4. What is the value of M4? 0. So we are adding here 0 plus, minus 16 plus 0, M5. We are going to use M5. M5 is 15 plus M7. M7 is 4. Right? So we will compute this. 16 plus 0 is 16 minus 15. 16 minus 15 is 1. 1 plus 4 is 5. So our resultant matrix is coming here 5. Right? Similarly, M3 plus M5. So let us see that what is M3 and M5. M3 is minus 2 and M5 is 15. Right? So 15 minus 2 is 13. So these values you are getting 13. Minus 2 plus 15 is 13. These values you are getting 13. Similarly, M2 plus M4. M2 is 3, M4 is 0. 3 plus 0. We are getting here 3 plus 0 is remain 3. 3 plus 0 is remain 3. Similarly, M1 we have already written here 16 plus, right, M3 was minus 2, right, plus M3 minus 2 minus M2. M2 was 3, so minus 3 plus M6. So we have to see that what is the value of M6. M6 is minus 3. So it is minus 3. So if you will solve this, what is the value? 16 minus 3 plus 3, 6 plus 2, 8. So we are getting here 8. This is based on Strassen'S matrix multiplication. So let us see that whether you are getting the same answer. 15, 13, 3, 8. 5, 13, 3, 8. 5, 13, 3, 8. 100% we are getting the same answer by using Strassen'S matrix multiplications. So what is important is we have to remember this formula of M1, M2, M3, M4, M5, M6 and 7. Then we have to remember this matrix formula. How you going to use these all 7 multiplications such a way that we are going to arrive on the same resultant matrix as we are getting from the regular matrix multiplications. Now question is, right, how we can claim that Strassen's matrix multiplication is taking lesser amount of time mathematically. So as we are knowing it that number of multiplications play a major role, and how many multiplications are used? 7, right? And since you are using the divide and conquer strategy, we are dividing the matrix into the 2 halves, right? So T of n by 2. So if number of element is 1, dividing of the matrix elements is not required, hence it will be 1, otherwise it will be 70n by 2. So in similar way, as we have used the other backward substitution rule for divide and conquer strategy, we are going to apply the same rule, right? What will happen if you use the backward substitution rule? 7 Tn by 2 can be written as T of n, so it will be 7 T n by 2 by 2, right? And we can simplify this as a 7 square T n by 2 square, right? Similarly, in third iterations, what will happen? 7 cube T n by 2 cube, right? And after I iterations, why it is required? Because we have to get 1 to terminate this, recurrence relations. So these recurrence relations will terminate for n is equal to 1. So we have to assume that n is equal to 2 to the power I. And similarly, take log both sides, right? And finally we will get it I is equal to log n base 2, because you have to take the log both sides on the base 2. So similarly, when n and 2 power I is equal after I iterations, this part will be 1. So we can write it after I iterations, you can write 7 to the power I T of 1. T of 1 means time complexity is 1. So this whole terms replaced by 1. So what will be the values? 7 to the power I. And what is I? I is nothing but log n base 2. So this can be written as 7 to the power log n base 2. Now by applying the property of logarithm, how you are going to write it? This n and 7 will be swapped. So it can be written as n to the power log 7 base 2. Alright? Log 7 base 2. So what will happen here? What will happen here? This log 7 base 2, log 8 base 2 can be replaced as a n to the power 3. Since this value is lesser than 8, so hence time constant will be lesser than this. So it is n to the power 2.8. And 2.8 is lesser than 3. Hence we can conclude that time taken to perform matrix multiplications using Strassen'S matrix multiplications is lesser as compared to general matrix multiplications. This is all about matrix multiplications by using divide and conquer strategy, and we have seen that this algorithm takes lesser amount of time as compared to ordinary matrix multiplications. Thank you.